Hello, everybody.
Hello,
Welcome to
everybody.
the welcome to the Houdini Illume webinar. It's been quite some time since we've done these. Very, very happy to be live again with Side Effects' Jeff Wagner, and already some stuff coming up in the chat. Hey, everybody. It's a good segue to talk about the logistics of this. Jeff will be presenting. If you've got questions, please use the Q&A. We'll be checking those for questions, and we'll stop at about maybe 30 minutes, 45 minutes in, and we'll deal with any of the questions that are in the
Yeah,
Q&A. For kind of like just general conversation and chitty chat stuff, you can use the webinar chat as you're doing now, which is perfect. So without further ado, Jeff, take
yeah.
us
Hello, everybody.
away.
Been a while since we've done one of these. Yeah, so basically I'm going to start off as I always do, having a bit of a discussion, and this one going to fire up Houdini, definitely go over the basics and then build it up because you never know who's going to be watching here. And then we're going to cover all the different ways, a few different ways in which you can use Houdini and how you can build up really simple systems into very, very complex systems. We're going to end up with the lab's latest biome tools, Project Dryad. If you're not aware of that, you should be. The tool set's still in alpha, but it is already on the content library with full videos. And it's about as sophisticated as you can get with copy and scattering approaches. And this is part of a broader series and look that look at Houdini and all things, and we're calling this everything proceduralism everywhere. Because we've seen proceduralism adopted by other applications, by other tool sets, by other thinking. And going back, way back 25, 30 years, proceduralism was exposed to developers. You could imagine writing code in a way that you were using functions as templates. And then you could build data structures within your code. And then you can create and deploy classes. And if you're using more object-oriented style software or programming environments, but the audience is very limited. So, they narrow the audience to developers. I think the earliest um, look at proceduralism was materials. So, it's one of my first introductions to proceduralism was in the late 80s, was to do with materials. Materials were the very first part of the CG pipeline that approached proceduralism. You can actually build shaders using building blocks. That's been around. I think Prism's had a tool called Lava, where you could procedurally build building blocks for what was then Mantra. And that point in time, Mantra was a pretty kick-ass scanline renderer, and it was soon to get ray tracing. So it gave everybody a really good taste of what procedural was. But proceduralism, when it comes to 3D, we first introduced the stack concept in Prisms. And the one neat thing about the stack is every stack had an operator associated with it. And every operator could take either was a generator or a modifier, a generator such as sphere, tubes, or primitives. And then all modifiers can take a group input and just a single wire. And you could connect those two operators together. And that was the first start of proceduralism with regards to geometry in a 3D app. So it's evolved since then tremendously, with just the sheer number of operators and performance, and really looking at a lot of the different ways in which we can create and modify these operators. Back in the Prisms day, we only had default attributes, those attributes that were predefined on the points. And that's where we're going to start today, because things such as a point scale, ID, normal or velocity, and all of those different attributes we had all the way back in when I was first introduced to Prisms in 1993. And this whole concept of using points as an anchor to do your work was one of the key ways that we work. So I thought I'd start off with a little primer for everybody, a little bit of a nostalgia trip. And uh, as I said, keep comments going everywhere. But this is the main point I want to make here with regards to Houdini. There are other procedural systems out there. It's a great time. Blender has their geometry operators. Very good. Very similar to the way that you would work with Vex or our own Apex, and that you have a lot of wires to control all the various different attributes to wire them together. Maya has a similar setup, not really as full-fledged as it was originally anticipated to be, but nonetheless, it is a nodal-based system that you can do some procedural things. And of course, the successor to that, which is a Bifrost, of course. And then we've got Unreal with their procedural content generator operators, which are pretty much all around instancing. And that's one thing that we're going to take a look at all the time, is when we're dealing with point clouds, we're obviously dealing with putting geometry on points. So let me go back here, and I'm going to unhide all these slides. Thank you very much. And hide them, and then how I unhide them. There we go. So now hopefully I'll have a slide deck that works. I did test this out. So where we want to go is, as I said, procedural everywhere. And what a great way to start looking at procedural setups and seeing how accessible Houdini is when we're dealing with these procedural systems. And it really is a great platform. It's very playful. You simply wire two nodes together, just a single operator, and that wire contains all the data that's cached and passes it in from one node to the other. And those wires can hold anything. And this is what makes this system quite unique, is that we can build an operator, or we can use a default operator in Houdini that can process any input geometry, whether it be points, polys, NURBs, VDB volumes, tets, agent primitives, Alembic primitives. And this system is engineered that we can add new primitives at any time. We've added packed primitives. We've added our own version of that, and even support nested primitives. And this architecture allows us to add new primitives. And it's the operators themselves, every node, that decides what it's going to work on, right? We can write a node that, and there's a very formalized way, both in the HDK or what the developers use to write these operators, and what we use as digital assets. There's all kinds of tools where we can filter the data on just what it is we want to work on, or whether we want to support different types of data, or filter it and do all kinds of really crazy stuff that we are used to working from, all from a single wire. So I'd argue, as far as accessibility is concerned, and ease of getting into a procedural system, there is nothing easier than Houdini when you're dealing with geometry. And it can get very easy. And then you add more and more layers. And that's where the complexity comes from as you build up your systems. And as I always say, is nodes in Houdini are multi-purpose, and we can expect the result in many ways. This whole thing about debugging is very important. We won't cover that today unless we want to go there. But it's a very cool way to work. So when we're taking a look at point-based scatter setups, points are truly the foundation of all the scatter setups that we're working with. And we have a copy operator. This copy operator, copy to points these days. And it's how you basically place the geometry on the points. And we've added a lot of sophistication. I think Houdini 18.5 saw the addition of a whole bunch of nodes that allowed us to do layered scattered setups, which we're going to take a look at today as well. We're going to build up a lot of these systems going forward. Now, the scatter setup rules. And these rules are immutable. They were set even before I joined SideFX in 93. Or I joined in 94, but I started doing work in 93. And they're there, whether we want to use them or not. This is what you do. So P is the location. It's the point position location that we want to place our copy on. Normals are velocities. And you can fight the system all you want. You might impart your own ideas or vision or background, but don't fight it. Z is the aim direction. So if you have a character and he's facing the X direction, yeah, it's going to fight you whenever you're starting to work with crowds, for instance, or any of the other tools that use the copy to points or the copy operator type operators. Yeah, it's that simple. Enter-v always points down the z, and that's where your object paces. So if you have a spaceship, point it down z. If you have a tree, I don't know if there's a front side, or maybe you're going to say, you know what, south is z and or z, and I have all the moss on the north side, for instance. You can do those sorts of things, but build that convention and don't fight it. Z is the aim direction based on enter-v. And then up is the up direction. So Y, we are Y up. You can set Houdini to be Z up if you want to go that route. But again, you then be fighting the system. So up direction is always Y. And in my systems, and I would adhere to that as well. And then finally, P scale. It's a float, and it sets the instance copy size, and that's an attribute you would place on your point. And then there's another one called scale. And scale is a vector that you can adjust both the X, Y, and Z. So the way you can approach scale and p-scale is scale can be the vector attribute that sets your X, Y, Z, and then p-scale could be the global scale that you want to. In our systems, rarely is scale used. I don't know why. I mean, I use scale for my own work, but what it happens is it adds distortion to all of your instances. You can imagine instancing a character and you're using scale, and for some reason you add scale and then Y is at a different scale, your character loses proportions or your geometry uses proportions. So that's probably why scale is rarely used, but P scale is the key operator that we definitely want to work on. And these are the base nodes that we're going to lean on when we start doing our little interactive demo. Hopefully I don't crash. So scatter and align is the key node that we use today to do the scattering. It's what generates the point clouds on our geometry. It's full featured. It can do simple to complex point scattering. It supports masks. It supports all kinds of really cool features that allow us to build layered scattering setups, and also to either include or avoid template points as ways of building dirt skirts or geometry or scatter points around our input points to create like dirt or debris. The next tool is copy to points. That's the workhorse. Whether you're copying geometry just to create really cool setups, or if you use packed inputs to create instances, packs you can think of as instance geometry whenever you're using these workflows. It's there for you to use. Attribute from pieces. It's great if you're bringing a library of geometry. Let's say you're bringing in a library of trees. They could be all over the place. We'll look at a really cool setup from Intagma that I still lean on heavily today when I'm teaching to basically how do you take an assembly of different objects and using a simple for each loop to create really nice. And you just put it in attribute pieces and it generates your named attributes for you, which work perfectly into copy to points. And finally, mask by feature. Mask by feature is where we do avoidance and where we can put points in hierarchical setups. So we can generate masks in many different ways. This is just a convenient operator that builds those masks for you. It can do ambient occlusion. It can do ray scattering, all kinds of really cool techniques to generate these masks. Very similar to what you would imagine in a game engine would do. So let's now fire up Houdini and see where we're going to go. So let me go up here and let me fire up Houdini here. So there we go. So we're going to start off, and I'm just going to put a simple object down. And by the way, if anybody has any questions, if you can just see if I should actually see if I can show I don't have a side panel right now, but I know there's a chat available, but I'll get to it in a bit. But we're going to start off with just putting a basic geometry down. And we're going to start up with what we always have done. So I'm going to put down some test geometry, and let's put down rubber toy. And the oldest schooled ways that we had for doing geometry, and it sort of shows you two things. First of all, we have take any geometry and we can turn it into a point cloud what we want with this node called the add saw. And this saw is old. It was in there in prisms all the time, and it's how we could generate point clouds from anything. First of all, it can create a point if you want. but it can take any geometry and just simply strip out all the data. And for this, I'm going to open up the spreadsheet so we can see what's going on. And I can say delete the geometry, but keep the points. Now the flip geometry has normals present on it. You can see here in the attributes. And that's why I'm saying in a procedural system, it's really nice to see what's on the actual geometry itself. And for the most part, the spreadsheet, as you know, is just used to just see if there's varying data on there and what's the attribute there. You could use the middle mouse button and actually see what that data is and inspect it that way. But I always like to roll this up. And this option says delete geometry to keep the inline points. What that does is it obliterates all the data. It doesn't matter what you pass into the add cell. You'll get a point. If it's a packed geometry, you'll just get that single point. And then from here, we could do, if these points were in a pattern, we might be able to do by group. And in this case, there's no really rhyme or reason to this geometry. So in this case, we just want the point cloud. Now we can put down a sphere, just as our base template geometry. And I'm just going to put down a primitive sphere. And then we're going to put down the copy to points. So this is our main workhorse that we're going to be working on. And this is the geometry to copy. And if we have our other points to copy to, and you have a really basic system. Problem we have is, first of all, the spheres are quite large and there's no real control over this. So you might be inclined, if you're an artist, you might be like, oh, I'm just going to scale my sphere down so I can go to here and I can change the radius, which is fair game if you want. And you can readjust the size of the spheres and you can get them so that they look okay. But I'm going to actually, I don't really care where the sphere is. I don't even care where it's located. Because I'm going to be using, I'm going to use a match size node, which I use all the time in procedural systems. And you can put scale to fit. And we can set the target size to be whatever we want. In this case, the target size is a bounding box of 1 by 1. And now, how can we control the size? Pretty straightforward. We can use an attribute called p-scale. So I'm going to just put attribute create, and one of the default attributes, I'm just going to put p-scale in here. And it defaults to 0. And we can see in the spreadsheets down, so we can adjust the size of this. And it's a float, so we can increase the value of the p-scale. So we can actually intimately control the size of the spheres. Pretty straightforward. And the next thing we can do on the match on the spheres themselves is we can add those one other attribute. Let's in the attribute create, we can put down an attribute. We can put an attribute adjust vector if we wanted to. And we can play around, not with the V, but with the normals that we have currently on our geometry. We'll play with that in a bit, but in this case, we can now, we can change the direction and length. In this case, we're only interested in the direction. And then we can go in here and change, and you can see how immediately the spheres are orientating to our direction vector. But really what you're going to be doing here for most of the time is you're just going to be just doing, adding some randomness or add some noise. Noise is nice because you can create an amplitude, increase the amplitude, and then you can change the element size of your noise, make it a lot smaller, make it larger, and you can animate the offset if you want to. But it's using P, or the position of the input point, to generate the noise, so it creates a pretty nice amplitude we can increase as well. And so the copy to points also can add some target points in there, but we just vector. And that also allows us to just how the points fit on our geometry. The last one we're going to do is attribute create again. This time we're just going to create the up vector. Then the up vector is going to be a vector type, and we can set the value to 1. It's always set to 1, pretty much all systems. And now we can see if we zoom in here, and I'm going to bypass and unbypass the operator. By the way, if you're somewhat newer to Houdini, the things I'm doing in the network are things that power users do day in and day out to inspect their graph. So I can quickly bypass and unbypass to inspect what effect this operator has on my network. done an awful lot. So we can see, yeah, fine. It does exactly what it says. It generates an up vector. So with a z and an up vector, we can now do that. We can sort of take also a look at the sphere itself. And we can add some directionality to the radius if we wanted to, or we can go to the match size and we can change the target size. Let's say the X size, which is hopefully the sideways. We'll set it to 0.5. And the Y, let's scale it up a bit. And the Z, let's scale that up a lot more. And you'll notice that I'm not seeing any difference in here because we have scale to fit. So I'm going to turn off uniform scale. And now we can see easily how our spheres are orientating to those vectors as well. Another big construct that we have is deforming structures with our workflow. So that's basically just using an old school add saw with the points. We can now put a scatter operator down in here. And instead of using the geometry points themselves, we can actually scatter some basic points on our geometry. So this is the old school scatter operator that we've had for years. It has a lot of controls for it. And I'm going to build a system. I'm just going to put a switch in here, so we can switch between the inputs. I always like doing this, so we can sort of play around with things. And I'm always thinking demo file when I'm ever doing these things. I'm thinking how best to build a file that I could distribute after the fact as I go. So now we have a basic switch. So we can switch between the points or the scatter. We can take a look at the copy to points. And we'll notice that it's not picking up any of the operators in here. So I'm just going to grab these these three attribute creates as well. I'll click them and then drop them on my wire here. And then we basically have the same thing. We can go up to the, that was alt click drag, by the way. I'm going too fast. Scatter. We can force a total count. But one thing we're going to have here is, well, you know, one of the tricky things with scatter setups is if we put a deform type operator up in here. And if I twist in here, if I add a twist scale, you can see the scatter. If I move my scatter flag down here and I hit the twist, you can see here the points are flashing all over the place. So scatter has a way of scattering by attribute, in this case in texture space. So the flip geometry does have UVs, and then I can increase the density scale on here. And it does use the UV map to determine density. And of course, if you have discontinuous UVs, you're going to have to, but it doesn't discontinuous scattering, but it doesn't matter. They're going to stick. So now when I do the twist, the points will actually stick. And if I move my display down to the copy to points, you can see very simply that we're now sticking. So these are the basics that you can lean heavily on when you're doing your scattering setups. Really simple setup. These rules never change. As I said before, they were in place since I started working at SideFX. And that's what is underneath everything that we do in Houdini, whether it's scattering on high fields, doing advanced systems, biome setups. And if you break these cardinal rules, and you're more than welcome to do that, you're now straying away from what in SideFX we call the norm. Right. So again, if you're used to other systems and you want to impart that misery on an old school Houdinizer, be my guest. But if it satisfies your artists on the floor, go for it. Just realize that you are on your own. So we have scatter setups. Now we have some other setups that we can build as well. On top of all of this, we can do scatter and align. So let's try the scatter and align now. Scatter and align is the modern version of what the scatter SOP does. And I'm just going to peel it off of this here. And so the scatter and align does some really cool things. So we can basically scatter on the surface. And we take a look at this. So the scatter and align is set up to do more complex setups. It's really geared for doing environments, density style, covering point clouds where you want to have some areas, you know, controlled with masks. So it really is all syncing and dancing. And it's like going from a really simple setup and all of a sudden you're being thrust into something that's quite complex. So the scatter align does take a lot of, a lot of playing around with to see what all the features that it has. So all we want to do is just basically mimic what it is we had before. So I'm going to flip this into the switch, and I'm going to go to the switch to the third input, and we're going to take a look at the copy to points, and we're going to take a look at the scatter align as it is right now. We have a single point. So we can control the point cloud by using a few different types of techniques. We can go by size. So it takes a look at the input geometry size, which is defined by p-scale, which right now is not set. So it might be a good idea for us to generate the p-scale. So I'm going to borrow this operator over here. I'll drag one over and drop it in here. So we can actually add some p-scale to our setup. And I'm going to set a p-scale of, let's say, 0.15 and do the scatter align. And we can adjust the minimum radius and the maximum radius. So what this is useful for is for generating systems based on our input geometry with a known size. And then we can adjust the uniform scale. And the coverage should give us a percentage coverage of what is 0 and what is 100%. So if we start taking a look at our copy to points, when we do our scattering, we can see that we can start to fill our geometry up, and by changing our minimum maximum size, we can create some really interesting looks. And there's other options in here by density. So we can control the density by coverage again, density scale. We can increase the density scale. And some other options, point spacing. So we can actually define the space between the points. All in ways of trying to get our points to evenly go over our surface without, let's put a minimum spacing of 0.01, without actually having any overlap. So this tool, with the old scatter SOP, it can easily create geometry that interpenetrates as you work. Whereas the scatter align really does want to try and create systems where you're not going to get very much overlap. And so that allows us to do some pretty cool work. There's a thing called tag, and we're going to take a look at that in a bit. But the tag is set to the point cloud. And what that can be used for is the copy to points can use the tag on the points to basically do differential type copying to the various different inputs. So with the scatter align, we can put a tag on it. We can rename the node because it's set to $OS, which returns the object string name. And we can call this to sphere if we wanted to. So, and now we can see the tag is set to sphere. And that's also one of the basics for doing hierarchical scattering, because we can put a second scatter on here. Let's set the coverage to be a bit lower. And something like that. Let's do a little bit higher. And now we can put down a second scatter and a line operator. So we're now starting to look at the hierarchical workflows that we have. And we can actually take the same piece of surface geometry that we want, but in this case, we can wire into the second scatter line. And in this case, let's call this box for now. And so now we can actually do by density or by number of points. And now we can scatter the number of points around those points as well. And if I hit a lot of these operators, escape and enter, we should see some template geometry. But if we go to the point generation, because we have our point cloud coming in here, and there's a little option in here called avoid constraint points. We turn that on. It now will take those incoming points and use them as constraint points. We can change and we can increase or decrease the constraint points on these different areas to sort of push the points around or to actually attract them to our seed points if we wanted to. And many times you'll use these seed points to generate density attributes as well. So that's the basics of working with this as well. Since we now have two sets of tags, I'm just hitting in the spreadsheet, I'm just hitting the name to just toggle between the two. And you can see the first set is box and the second is sphere. So this now opens up the opportunity for having two different types of geometry. So we can have a sphere and we can put on a box. And after these two, let's actually put that into the middle, and I'm going to set the uniform scan to 0.5. And I'm just going to use a name operator, a name SOP, and I'm going to call this sphere, and then call this box. So the basics of the scatter align, this could be anything that you want. You can create this however you want. Just call this box. So, and the box should be unit size as well. Actually, it's fine. And now we can merge these together. So we now have a sphere in a box, and now we can put this as the geometry that we wish to copy. So I'm going to move that over to here. And the copy to points now puts a sphere and a box on each one of the points, but we can now use piece name as name. And then the target points. So actually the piece name, I think by default, it's set to, oh, if I were to actually use this, that would be good. And so now we have boxes on the main points and spheres and all the other points. But actually, let's go to that. So scatter and align box, sphere, and the name is called tag. So actually, the piece name should be tag. And we can change the names to tag, and it should all work. Oh, I did this all wrong. I'm sorry. The attribute should be name. I'm sorry about that. Yeah, it's problems with, that's the default attribute. And here I should have put the, I'm sure some of you caught this already, but sphere and this guy's box. And now I can go back to the copy to points and actually use that as name. Or in this case, can use tag. I think they all have to sort of line up. So I'm going to change that to tag. And there we go. So the one thing that's a bit fussy with this system that I'm glad I sort of waffled on this a bit, but whether you use name, tag, class, I've seen some people use class or other identifier, they all have to match. So when we're using the copy to points sets to tag, the scatter and align is using a tag attribute. And your name operators are also set to tag. That's the system that I always use when I'm building up these workflows. You might watch YouTube videos that we're using or demos that use different setups. I just like to, again, least defaults. I'll always use tag in my setups. So names, instead of using the name attribute, I'm using the tag attribute. It's on the prims. And this scales wonderfully. You could have 40 different versions of trees. And again, the attribute from pieces is the node you want to use. I could pack these if I wanted to. For instance, if I want to turn this into an instance setup that I then want to send to a game engine or send to Solaris as instance workflows, I can just simply do that. And what that does is the copy to points intelligently will just pack the sphere once and the box once. It does that as a pre-process step, and then it'll create pack prims for all of my geometry. And if I hit the info button on that, you should see all the pack primitives now ready to be instancing with single points. Okay, so I'm just going to go up now, and there's a help card that ships with Houdini. And so there's the scatter and align help card. And let's take a look at that for now. So the help card does something really simple. It just basically brings that in and it looks all happy and it works quite well. But I've extended the help card for this example today. I like to build out the help card so that it actually showcases a bit more of the functionality of the scatter align. So I really do hope the help card gets updated to this, and that would probably be on me. But the way I've done this here is again, same thing. Tag, tag, and then scatter align is set to tag a sphere. So this is now it becomes a really great example where it shows hierarchical scattering once again. So we have original scatter operator where we just scatter some points on a grid. And then we adjust the p-scale. Attribute adjust float is, I really like the adjust operators for doing attributes. Attribute adjust whatever you want. I really tend to use these more than anything else for creating and modifying attributes. And then the second scatter is using that input like we saw in the first example I did. And this shows you some of the really cool operations we can do. Again, avoid constraint points builds in this relationship where by adjusting the radius scale, we can place all the points on the inside if we wanted to capture those capture points. Or if we're doing some debris around our pieces, you can actually push this out and start generating some debris around the outsides. And this creates a point cloud around the debris. And again, using this to tags, merge these 2 point clouds together, and then we can do the copy to points. And we have our hierarchical system where we can now see we have boxes with some debris around them. So a really simple setup. Now I'm going to pause a bit and take some questions because I see the chat is going on. So if there's any questions on this yet? Nope, not yet.
Hey, Jeff, yeah, we have some questions.
Oh, okay. So I'll pause here and let's have some questions now.
And everyone's behaving really nicely in the chat and keeping the questions in the Q&A, which is perfect.
Oh, fantastic. Oh, we do have the Q&A. Okay,
Yep,
got it.
yep. Can you see that as a panelist? Can you see the Q&A or no?
I'm going to see right now. I can see the chat.
Yeah. Anyway, if you can't.
Yeah, I cannot. Well, let me do more here. Yeah, keep on. Yeah, just start firing away.
Okay. So when using Karma XPU to render forests, should we use opacity maps for leaf shapes or create actual geometry leaves using trace node? I know some renderers struggle with zillions of instanced opacity maps.
So the answer is, when you're doing with leaf systems, you have to use geometry. And in Houdini, what I generally do for forest systems is I create just like everything else, I create 3 different types of leaves. One is hero leaves, which are fully modeled, doesn't rely on displacements. It does rely on displacements for the surface, like the veins and the subtexture, but the actual shape of the leaf, I'll actually model that in. And my second version of the leaf will be just an outline of the leaf. So it's just a primitive. And I might divide it in the inside, whatever's the lightest approach. So I'd actually just have a basic surface. And it might have a spline on the middle. And I'm, depending on the render engine, if it's Karma XPU, I might just use bumps. I probably wouldn't rely on displacement for leaves because it goes up quite a lot. And then the third version of the leaf was I'll actually use a line, which is pretty cool. So one of the things you can do is you can just put down, I'm going to just put down a line sop here. And if you create a width attribute, I can actually make this line wide. So for leaves, I'll actually, so for that very foreground background trees, I just use lines. And it's even lighter than using points and instancing. Just use, not feather width, what am I doing? I want to put down an attribute, adjust. Let's do attribute adjust float. I said I use these times all the time, and I do. And we're going to add a new attribute called width. So width is one of those classic environment variables. We had width when we were doing RenderMan way back in Houdini, early versions of Houdini, we had this width attribute. And if we give it a width, and I take a look at my spreadsheet, let's take a look at point attributes, I can actually determine how wide this curve actually renders. And if I had my display set up correctly, you would actually see this line rendered with a width. As a matter of fact, well, let's do a mantra, old school mantra render, because it works the same way as Karma. And you'll see that the line will render with a width once mantra fires up, I hope. Well, because I don't have any, should have a headlight. But there's a second attribute that we can add called orient. So I'm going to do an attribute adjust float. And so an attribute adjust float, I can actually set this to you can set it to a normal or an orient. And in this case, you can set it to a normal. And as soon as you have a normal, you're now controlling the direction that ribbon renders. So you can, if there's no normal present, it will always face the camera. So the width will always face the camera as you render. And if you add a normal, you can actually adjust whether it's on or off. So that's great system. So again, it's geometry, please. No, don't use opacity. Because as you said, yeah, most ray tracers and path tracers really don't like having a tremendous amount of opacity to deal with. Lately, that's Gaussian splats. Gaussian splats can represent a really hard solution for a render engine. Yeah, just use geometry. That's the answer. So
Cool.
next one.
This is more of a comment than a question, but it's Eric is looking to learn how to get control over X scattered around B and density as well. So it's great hearing your wisdom around the process.
Yeah, so we're going to go there next.
Cool. Next question is from Marlon. I've been modeling some procedural objects in Houdini, but when I export the model to Unity, all the meshes get merged and I need to learn how to convert an FBX with all the parts. Is this possible?
Yes, it is. So if you have the installer. See if I got my installer here. Make absolutely sure, first of all, that you have the labs tools. So I'm just going to install today's daily build, for instance, and I'll just show you in the installer, there's a Unity plugin. Absolutely have to have that Unity plugin turned on, and that will install all the Unity tools. And once that's done, you can now start leveraging the interface between Houdini and Unity. And there is a method, which there's a few tutorials out there that actually show how you can use the labs tools to get a complex copy setup, instance setup inside of Unity. Same thing for Unreal. As a matter of fact, I'm going to be showcasing one example tutorial in Unreal where we can use these point instance setups to bring geometry in, but the same thing worked for Unity. Yeah.
This is again more of a comment, I think, but the help cards used to come with a lot of the example HIP files. Now they don't. Can they again? I love that.
Oh, if they're not there, then that is a bug. Yeah, that I take that seriously. The reason why, especially with 20.5 now, we have recipes, and that becomes even more important because recipes, we have a little spoon there, which I guess is colloquially used, like, I don't know why it's a spoon, but you'll see that all the example files show up now under here. So this really amplifies the issue of when these example files go awry, and they're amazing, right? So for instance, we could do line direction, and that builds a new tool for you, and it gives you. So we've made them even more accessible in here now. You can even take a look at the recipe help if you wanted to see how to make these recipes. There's node presets. We can save partial node presets. So yeah, it's a recipes is huge inside, introduced in 20.0, but really built out in 20.5. So yeah, there should be help cards.
Next up is from Gina. What's the difference between a height field scatter and other scatter tools you will cover today?
Oh, so height field scatter. I don't actually have height field, so let's do one now. Because I'm going to go back to the help card. We're going to start, we're actually going to take a look at a more complex version, but height fields are great to work on. So let's build up I was trying to look for an example file and I got lazy. So let's do a height field and let's put down a height field noise. Let's just create some interesting noises on here. And then we have a height field mask. Height field mask is, if I can type, and we actually have mask by feature, which is an important tool. And this allows us to create height fields based on masks. And let's now put down a height field scatter. So no different than the scatter tools that we've been using before, in that you need a terrain. And you can see here we've got a crap load of points. So, but these are evenly distributed over the entire terrain. And then the second input is where we can put, if we want to put a mask or scatter, so now we can scatter inside that mask area. And now you can see here, we now have these points. And what's really nice about this is it'll actually construct a normal for us. So the normal itself will give us the surface normal. And so if we wanted to copy, let's copy some really simple geometry, test geometry. Let's put down some more rubber toys. And again, copy to points is our weapon. Copy to points. And again, this is the geometry to copy. And then I'm going to see if I can reduce the number of points. Coverage, let's reduce the coverage tremendously. So you notice that height field scatter has very similar parameters to scatter and align. We try to make these two operators very close. Now, many times I'll be in here and I'm always popping up parameters. I did that way too fast. I'm always popping up floating parameter panels for two reasons. One, it gets awful annoying when you're bopping between SOPs and the UI always changes. Whereas if I have nodes and I just want to pop up a parameter, I can actually pin this if this stays up for as long as I want. And I can start taking a look at the different operators. In this case, let's compare the two. They share an awful lot of properties, tags. You can actually do avoidance on the tags. They support the same tags as over here, tag name, same tags. They're both are interchangeable. So for instance, I could do a height field scatter some points, convert the terrain into some geometry. Maybe I want to do some really cool Boolean work on that, put it through a second scatter on a line, but using different tags or the same tag names. And then the copy to points will use these tags to place all your various different pieces to it. So everything I'm showing you is very modular and very scalar. And if it doesn't, that means we skipped a beat and we have a flaw in the logic or the design philosophy, or we've decided to change the design philosophy between a release, and we'll rarely, if ever, do that. But anyway, so they both have a similar workflow. But anyway, so we have our height field scatter. We can do scatter to points, and there we go. And now I scattered way too many flippies, and I hope I don't crash. Ah, yeah, I have an old machine. So more questions while I furiously hit escape on. Oh,
Yeah, here's a question from Mark. Do the inbuilt nodes have functionality to scatter smartly based on the complex shapes of the library of objects that will be instanced onto the points? For example, a rock that is much longer in one axis than the others, or is the avoidance only based on the spherical radius?
Let's dive into the Entagma example. And let's answer that question directly, because that's exactly where I want to go to next.
And Jeff, let's use that as a segue to keep going with your presentation. We'll come back to the
Yep,
the other
for sure. Great segue.
Good.
So the Entagma example, which I'll give you to a link afterwards, is a really great example of doing scattering and alignment. So he takes in a field of leaves, and this could be anything from trees that you're bringing in. It could be megascans files. It could be 40 different types of canyons, rocks, features, whatever you want. It could be leaves. In this case, it's just an array of leaves with UVs on them. I don't have the materials set up, but you can see they're all set up in a very GameX style fashion. Leaves that index into a texture map. Again, notice no opacity. There was a question on leaves before. Don't use opacity. Use actual shapes of leaves. And then what we can do in this particular case, now that the problem space we need to do is we need to create a piece out of what it is. We could have simple leaves that are just defined by a simple closed shape. It could be a piece of geometry that is completely manifold, just a single piece of geometry that shares all its points. But if it's an actual assembly, let's say a car, let's say you have 20 cars, there might be, there's got all kinds of different meshes on it. You might want to pre-process each car before you bring it in to turn it into a pack prim. So you want to, there's a bit of work involved in turning each car into a pack prim. But other ways, the problem space here is at the end of the day, we just want to have a single point primitive that can be represented. So we might have to pack all of our cars in here. But anyway, this is a really great logic. So the problem where we want to end up is just a single point per primitive. And that's exactly what we have with these leaves. So we use a connectivity operator. So the strategy we can use with single prims like leaves is if you have a library of 100 leaves, you can use a connectivity operator. And what that does is it takes a look at each prim and sees whether it's connected to anything else. And if it's not, it'll give it a unique number. And that number is an attribute called class, and it's at the primitive level. Welcome to Houdini. We have different types of attributes for points, vertices. In this case, the normals are on the vertices. Primitives, and we've got this really cool detail attribute where we can set and modify without cooking the geometry. So details are pretty sneaky. And there are great ways of adding metadata to each primitive that we have. But anyways, we have our primitives, and we can see here it's added a class, goes 0, 1, 2. So each one of the prims now are part of a class, because we can see here this leaf, for instance, has 1, 2, 3, 4, 5 prims associated with it. But since they're all connected, they'll all share the same class attribute. That's what connectivity does. And stepping back again, we just need to have a single point. The leaves are all over the place, so I love match size. Match size can take anything and move it to the origin and also make it unit scale. Remember, that's one thing we didn't talk about, but a lot of these instance systems really want your geometry to be unit size, centered around the origin, where a Z is the aim direction. Look at the little leaf here. It's perfectly done. So the root of the leaf is negative Z, and the tip of the leaf is positive Z. I consider that perfect, except I would have moved the root of that leaf at 0, 0. And again, match size can accommodate that. Going over here, we can say in Z, we can say the minimum, or we can say maximum. So now I've got all my leaves. So roughly the root of the leaf is now at the origin, and then the leaf goes out towards in the Z direction. And Y is up. So you can see, yep, that's my geometry is looking good there. But anyway, we can do that match size. Then we can do connectivity gain to create an attribute called class. And then over here, what he's done is he creates 3 pieces of geometry. So we're now creating the environment, and we merge a ground plane. And I built my own geometry here. And then we can use a tool called mask by feature. And this is where you can create a mask attribute for doing shadowing. So for instance, if you have some trees, some rocks, or some bigger objects like buildings, you can use mask by feature. And what this does is it actually creates a mask. By the way, I hit escape, enter. Sometimes Houdini's viewport gets a bit lazy, or you sometimes have to do that to sort of kickstart the state. I do that so quickly, escape, enter, and then you can see the attribute. And here we can change, there's several different ways to create the masks. In this case, we can do direction vector, we can cast shadows, we can do self-shadowing as well. We can also, there's different ways in which you can do ambient occlusion as well. So you can feather things out. So this is the tool you want to use to create a mask, to create more complex systems where you're not having to compute, and you don't want to touch the geometry in a lot of these systems. You don't want to interrogate your tree. You don't want to build representation, because you could be building out a system that could have thousands of different tree types. And so you want to use mask by feature to basically scatter your base points, or take a look at your terrain, mask by features, and then you can work that way. And then you can do scatter and alignment based on that. So scatter and align, by the way, the mask by feature is creating it's putting that height field or that attribute in an attribute called mask. And if we take a look at our points, we can see mask right there. So you can paint in the mask. There's a whole bunch of different tools you can do to modify or generate this mask attribute. But mask by feature was also created in Houdini 18.5 when we renamed the original instance points node to scatter align, and also copy to points. All 3 of these were worked up in Houdini 18.5, and they worked together as well as attribute from pieces. So all 4 of those construct the basic core of what is scattering. So scatter align, you can now see the points are basically using that mask, density attribute mask. So however you want to generate that mask. And same thing works for height fields, by the way, when you're doing scattering on height fields. And then we can do attribute randomize, some piece scale, and then we can do the attribute from pieces. And what this does is it'll take a look at all the different leaves coming in, and it creates a class attribute for each piece. And then it places that class attribute on the point. So what it does is this input, it just takes a look to how many pieces are in there. In this case, we have, um, I guess how many primitives. Basically, it's using the class attribute. You don't even have to think about it. So if you wire that into the attribute from pieces, this will simply query how many uh, pieces are in the attribute called class. And then it will then, every point that comes in, it assigns it a unique number from that class. So it'll go, so you can see that each point now has a different class number going from 0 to the number of pieces that are in here. So that does all the heavy lifting for you. There's all kinds of controls in here. We can shuffle pieces. We can change the seed. Actually, and this all works with copy to points. So we can see here, now we got our leaves copied to our point cloud. And let's go back to attribute from pieces. We can change the seed. And what it's doing is it's just shuffling the index of those primitives. It's just cycling those primitives onto our points. And we can offset them as well. So it's just basically creating a different setup. And promotion, yeah, there's different, but basically we can do cycle, we can do patches, and now we get even more controls. So if you wanted to place grass or different types of pieces, you can create patches of, this is great for doing grass or rock scatters by patches. You can just add random noise as a determining factor as to what pieces we want to add where. So you can add weights and biases, and you can have more one type of leaf than another. So you can imagine class 0 to piece whatever 64, and right now I'm saying I'm scattering the majority of my pieces from here to here. Whatever pieces are falling within this ramp from 0 to 1, maybe it's piece, I don't know, 20 to 28, is getting a higher weight of the distribution. So yeah, there's different types of random, just pure random scattering of pieces. You can also use a texture map with IDs, or if you're familiar with writing vex expressions, you can start writing expressions for more complex work. Not necessary for the majority of the work we do, unless you like writing vex. And there's copy to points. Now, what I did is to answer the question is, hey, what happens if we add a tree? So, and I built some trees over here. I just built a really simple tree. And I have a scatter align here, so let me do a scatter align to, I think I did it to that. Yep. And I did a copy to point. So I just copied a few trees on that same terrain. And then I can merge in that with this guy, I think is what I did. So I got everything merged together. And then I can do a mask by feature in here. And this gives me, well, you can see the top of the trees. I can exclude the trees. We'll ignore that. But for now, we can now see that we're generating a shadow mask based on a direction vector 1. And we can change that director a bit if you want to skew that. But this works very well. It's very fast, highly optimized. And we can change the angle as well if we want to. And we can also use ambient occlusion if we wanted to add a little bit more blurring to that. But this is one approach in which you can do it. And this is all based on hierarchical scattering. We're now starting to work on a really cool system here, where we're using scatter align as a tool to place some of the primitives, and then using mask by feature to create a second workflow. So we can now put that into the scatter align over here. And now we can see we no longer get leaves falling under the tree as well, or maybe it's something else that we want to scatter. So that is one very powerful approach, and I use this approach a lot. What makes this really cool is that it's fully procedural. If I change this scatter alignment, let's change some of the seeds, the global seed. I can move my trees wherever I want, and you can see the trees as they jump around my terrain. If I template this, you can see how I can do avoidance. And this scales very well, very fast to very high resolution workflows. So these could be rocks, they could be boulders, they could be twigs that I don't want things to be around, or so this is how you can create a hierarchical scattering approach. So questions? So I'm going to take a look at the chat now. So
We have a lot of questions.
okay, we're going to stop for a bit. Okay.
Uh,
You can see them. Did you clear it from the last time we did it?
no.
Okay, so I'm going to go from if I need to scatter objects in a game engine, okay. Oh, we did that one. So, let's answer that properly. If I need to scatter objects in a game image, how to retrieve data from game assets like bound or simplified mesh? So the answer is yeah, as I said before, install the labs tools for Unity, and there's a way at actually getting at the Unity data and passing it into a digital asset right inside of the game engine. Yeah. So the next one is once our setup is okay.
You can see these questions, which is good.
Oh yeah, yeah. And another one is how to get objects scattered on a surface not to intersect. How do I approach that? As I said, scatter a line. If you add in a point cloud into the second input and you give it the right p-scale attribute, scatter a line will already try to do that avoidance. We saw that in the help card example where that's right, the help card example is I broke the help card example. Yeah, because yeah. Let's see if I can fix this. I'm hitting frantic. Okay, there we go. So the help card example. So naturally, scatter a line, if you put in the second point and you give it the right p-scale, it'll try and already use those initial points, or it could be any points that you generate. So for instance, if it's a game workflow, and I know what prims are on those, or actors are on the various different positions, I can take a point and I have a rough idea as to what size it is. I generate its size. I can then adjust p-scale and do it that way. So scatter a line instinctively when you turn on avoid constraint points wants to do avoidance to begin with. As well, scatter a line if you're using tags, it really tries to, by default, avoid intersections. So it's not like that. I would never use a scatter SOP these days because scatter SOP, it's so easy to get interpenetration. Where scatter a line already gives you different workflows by size, by density, by point spacing, a number of points that are already designed to try and avoid intersections. And then, as I said before, building in strategies with hierarchical scattering, where you can use mask by feature if it's using geometry, or using clever masks inside of the height field tools to do the same. Using those sorts of strategies, using hierarchical scattering and taking advantage of tags to basically, at the end of the day, just copy. So every one of these scatter lines could be set up to just copy one specific class of objects. Let's say this scatter line was just used to do leaves, another one to do trees. You can do another one that does rocks. So it's up to you to determine what hierarchy you want to build up. So obviously it would be rocks, because trees can't grow on rocks, right? Or maybe you want it the other way around, where you place your trees first and then you want to scatter the rocks so they don't intersect with trees, so on and so forth. And again, all driven by masks.
Okay.
So the next one, once our setup is done in object context, is it recommended to export a point cloud with attributes, tag p-scale to then use a node instantiated in stage context? If so, can we have some advice to do this setup properly? So that's when you're bringing things into Solaris. So what I'm going to do here in the copy to points is I'm going to be cheeky. I'm going to do a really quick Solaris setup just to bring the leaves in so that each leaf becomes an instance prototype. And the way I can do that is using this single option on the copy to points called pack an instance. So if I turn on pack an instance, I now no longer have geometry. I'm now no longer thinking about, am I getting this into a game engine, or how do I deal with this to get it into other applications or workflow? I'm now thinking I'm going to want to get this into USD, or I want to get this into Unreal or USD because I know those pipelines support pack primitives in the converter. When you bring those assets into Unreal and Unity, they'll come in as instance prefabs. So, or instance geometry. So if I do that, I now have a whole bunch of pack primitives. So each leaf is now represented as a single point with a pack prim. And there should be only as number of classes are in there as types of primitives. So now what we're going to do is we're going to put down an output operator. Why an output operator? Because I know no matter where my display flag is in this whole tree, current convention, as of the last few releases of Houdini, is if you put an output operator in your tree, this is what goes out to display and render, no matter what. As well as when we're going to USD or to Solaris, I know that out of this whole mess, that's what's going to output. And whether or not it's got a display flag. So let's actually give this a really good name. It's called out leaves. Now I can put down a Solaris graph in here. So a lot network. If I wanted to, I could go to Solaris. Actually, let's do it properly. So now we're gonna go to, you know what? We're gonna just put a Solaris graph in here for now. A lot network. And that's going to be, and I'm going to dive inside of here and I'm going to put down, okay, SOP import. And I'm going to point it at my parent, which is relative path out leaves. And now what I get, it's pretty cool. So there's my SOP input. I already get instances. So all you need to do is just turn that one option on the copy to points and you get instances. And we can see that we have, oh, we don't have unique prims. I think something's going on there. So we might actually have to create the packs in the for each loop, but that should work. I don't know why it's not prototyping. Let me go back up again. And I'm not going to trust the copy to points packing because maybe it's not doing what I want it to do. But in here, we're going to put a pack operator. We're going to put a pack node in here. And then we're just going to do it that way. So the pack operator is now creating, for each leaf, I'm making a pack prim. And hopefully that will work properly now. And actually, it was working fine. Here's my prototypes, my 76 prototypes. I'm screwed up. I'm sorry. Didn't look at the prototypes. I can probably bypass this and turn that option back on. Yeah, my fault. And let's go back to the LOP network and let's take a look at a prototype. Same number. I actually did the same thing the same way. 76 prototypes automatically created for us, and then they get instance onto our leaves. So if I was doing trees, this is the way to do it. So if you just want to do leaf scattering as well. So, and of course, to complete the mission, we can put down an environment light. Let's put down karmic physical sky just because I like it. Put down a karma operator, and then you can start rendering. And then we can go to karma. There's no materials on it right now, but you get the idea. Now my machine is, it's over, I think it's over 5 years old. It's got a really pokey graphics card, so it's just a 2080 Ti. So this will be a heck of a lot faster with modern hardware. But anyway, there you go. So that answered the question.
Cool. So
Yeah.
let's go up to the top of the questions. So we'll start with Eric asking for
Yeah.
any tips for tightly scattering geometry of non-uniform shape while still avoiding overlap. For example, a stone vault or a wall.
Okay, so it's a stone vault or wall. that's so the approach you would take for that, um, that's so that it. I'm trying to think there's my brain is going in several different ways. There's different ways to do this, so I'm trying to find the most straightforward method to do that. Um, One of the ways is how you're actually building the stone geometry. So the question I would have is two. A, am I working with an already pre-existing uh, set of rocks that some artist has built and I now want to build a wall from those rocks? Or do I have the liberty of cleverly cutting up the wall and then constructing with a for each block rocks from that wall? So let's do the former one because that's one that I think is more in keeping with what it is you want with the scatter setup. So let's assume it's the first where you have a collection of rocks and you don't want to build a wall from those. If you want to build a really good looking wall, and they're really irregular rocks, I would probably build some sort of stacking system using ray intersect or RBD. I would probably pad my rocks out using an expand operator to pad my rocks out and then build a retainer. So you might want to do something like this box. Um, that would be one way. So if I really had to work with some
Yeah.
geometry. Yeah, go ahead.
Sort of interrupt, but Eric added some context in the chat.
Oh,
Um,
he did.
just to us, so no one will see this. But he said, "I think the existing assets handmade by artists is the best fit. I've tried to use a trick with UV layout from Intagma, but it requires UVs on the template geometry, and it seems the UV layout sorts the input shapes by size, which creates an odd pattern."
Yes. So so I've developed a few different techniques in the past. One of them is let's say I've got let's say a 12-meter long wall. I'm going to trim my templates off. And it's say 4 units size. Oh, it's quite high. So let's say it's 2.5 meters high, and it's let's say 1 meter thick is a good wall. So, and let's say I have I'm going to do something really horrible here. Just put down a box. And the box, I'm just going to make it a size, make it unit scale. I'm going to add a few more divisions. And let's make it a bit smaller. And so then you could, so you could have you could actually scatter some points in here. Turn it into a volume. The ISO offset. ISO offset generates an old school volume, which works just as fine as VDB for these sorts of situations. It's really good. And I can ISO offset's just a really great way of generating volume. So it does a fog volume ray intersect, and then I can increase the sample division. So I can create a fog. Let's do 100. And then I can scatter points inside of the fog volume. Hey, the scatter example. And what I might do, something a bit more clever, is I might in here put down transform. And I'll just scale it up a bit. I'll show you the reason why I would do that in a minute. So let's do a scale and Y. So I want to make the box a bit taller. And the pivot I think the pivot I just want the pivot to be whatever this box pivot is. Copy parameter. I'm going the wrong way. 0.5, I think. So I just want to basically lower the box so that it's down on the ground again. Actually, I think it is actually 2.5 or whatever that height was. And then I can use a copy to points. Like you can create some really clever systems. Geometry to copy. And then I could use a simulation like a bullet sim to sort of pack the wall up. I could do it that way. And then just use a bullet simulation to pack the wall up. Yeah. That'd be one approach to it. Many times when you want to address something that is physically correct, yeah, you can use a physically correct approach. You could do it that way. Another approach I've done is um, yeah, how can I turn that into a collision object that is a container? I think I went the wrong way, by the way. Yeah, but yeah. So you can use a rigid body system to sort of drop the rocks. That'd be one cheap and cheerful way of doing it. My setup is kind of whacked here, but another way is to use a stacking system with a for each. And you can start with some points that you scatter on the base. And then you can do a for each test for this distance and stack your rocks that way, which I've done before. And you want to process the rocks that are coming in there. So if you have a rock with that's very wide and narrow, but it has a really irregular shape on the sides, you can spin that, you can use a for each block and spin the rock around on its favorite place, on its favorite faces, and then pick the face that most best represents how to put the rock flat. And I think there might be a labs tool that does that. Um, no, I'd have to take a look at my research. But yeah, that's a really good question to take offline and address. Yeah. Okay.
All right, next up, Eric is asking, often in production, we have custom sets, set ground that are more cartoony and not realistic. Our height field system scatters only for a base ground that is a height field. Some tutorials showcasing scattered environments start with a height field. That's why I ask.
I think height fields are just more accessible for terrains. Nothing's stopping you from putting down a grid and using geometry. Again, let's put down a height field. Let's put down a height field. Everything starts with a height field, and let's put down a H field noise. And let's generate some noise on that height field. And let's use something, let's use boot terrain. No, I'm just going to use the simple purlin as well. And let's actually reduce the number of octaves to make it a bit smoother. Let's put on an H field mask by feature. Feature points. So we can start off with that. It's pretty easy to scatter some points on that. What I've been told by quite a few games teams, I just use these tools and I get feedback, but I've been told by quite a few games teams is they absolutely love H field convert. Uh, uh, convert height field. They absolutely love this tool to convert height fields into polys. It's built into quite a few games pipelines that use height fields as masks. They'll quite a few times they'll convert to polygons and then they convert it back to height fields, or they convert it to polygons where it makes a lot more sense. And as well, now you can start scattering on this using scatter and align, for instance. And now you can scatter surface. Now you can scatter on the polygons as well. And you can generate the same sort of masks that you do with height fields as well. As a matter of fact, if you convert the height field from here, It might even, yeah, it doesn't give you a mask attribute, but yes, so you can do that as well. So you can scatter both ways. It really doesn't matter. It's just that there's a lot of convenient tools around height fields. For instance, the height field mask by feature, for instance, is a great tool. So it's more accessible, easier to teach. Whereas if you're doing convert height field here, if I wanted to interrogate the surface, I might have to use a curvature operator, or a measure operator. And I can interrogate this distance. I can measure the area. I can measure the gradient. And then I can use that as a mask attribute and work with it out. I can call it masks, for instance. And then I can use that to scatter into that attribute if I want to measure. Stop, escape, enter. Yeah. So you can use the measure operator to build, your own attribute biases or weightings. Why is it going? That's just a color mapping, by the way. And then you can use a scatter line based on that mask. So if it's by size, by density, and then you can use a density map or a density attribute. I'm working with a big terrain, so I need to be very careful. But anyway, then you can use a density attribute as well. And that density attribute can be height. And there you go. So you can get similar controls. I think it's just simple accessibility. But this gives you, I would say, more control than using this, where you need the control. That's all. So hopefully that answers the question. I should save this file in case everybody wants to get it
I was going to
afterwards.
suggest, Jeff, that we distribute the files afterwards. I think we should.
Yeah, for sure. So yeah. So the next question: do these scatter tools work?
Well,
the
hold on,
same?
Jeff.
Okay.
Just letting you know. Let's do a quick time check. We've got 40 minutes left. So
Okay.
do you want to address the questions right now, or do you have 40 minutes more of content, or how do you want to
I
balance?
have about another 20 more minutes worth of content.
Okay. So let's
So we
take
cover,
maybe two
yeah,
more questions, and then we'll get back to content, and then we'll come back to questions.
yeah. So the last thing I want to take a look at is definitely taking a look at, there's a couple things. So Adam's going to be doing a workshop in the next coming week, and he's going to be doing some cool workshops. I thought I'd just give a little bit of a breakdown, and I believe this is going to be recorded for distribution later. So you'll be building this in the first segment, and it's covering exactly what I showed you, but with a lot more fidelity hands-on. And it generates a terrain system like this. It doesn't build the avoidance that I showed you, but that would be very easy to add to the system after the fact. It's just that we need to be able to build a system for people that are sort of new to Houdini to be able to get up and running. So we had to choose our poison, and Adam did a great job. But this is the file that he was going to be building as he goes forward. Again, attribute from pieces, attribute to just froze, copy to point. It's the same thing over and over and over again. The only thing is if you get a power user that just absolutely adores Vex, and unfortunately there are quite a few of them. To all the artists in this audience, you do not need to know Vex to do the most advanced workflows. Can you use Vex to simplify some node operators? Or maybe after you've built your system and you need to optimize one particular part that's taking a long time? Absolutely, you could then rely on Vex because Vex threads by default. And so that would be a great solution to apply, for instance, to very complex, if you have a ton of points and you need to process them, maybe doing ray intersection tests or something. Yeah, then it makes some sense to deploy Vex. For the majority of the work we do, no, you do not need to know Vex. So if you got some power user out there that says you have to use Vex, the answer is at some point in time, but you can certainly do production work and deliver work without that. No doubt about it. But anyway, here he's got all the different pieces and he tags them all. So here's a particular tree that he's working on, and he builds it with all the data. So if I go to the prim type, he's got branches and leaves. So he's managing leaves in this particular example, and he just outputs the trees and he processes them so that they're ready to go. And notice how he does a match size so that they're all unit size, roughly one by one by one. So it's, so it will work quite nicely in the system. So there's all the trees that are coming in, and he's relying on name attribute. As I said before, the problem you need to do is you need to classify whatever it is you're working on with either a class attribute or a name attribute on a pack prim. And then from there you can do attribute from pieces. And this is what assigns the point cloud to each piece. And then you can do a copy to points. So that's set up. Again, it's the same thing that I've been showing over and over again, just a slightly different way to work on that. Now, the next thing is what I want to look at now is a different file. And this file is really cool. So what happens if side effects spent with labs better part of a year and a half to 2 years doing research and building out a biome scattering system that simplifies all the rules using scientific methods to generate plausible height fields that are similar, because we did talk to a lot of customers, and I like black backgrounds, so let me turn my background dark. So we did talk to a lot of customers. Does this pipeline fit into it? And the way that works is these can all be assets generated by artists. And this whole height field system. And by the way, this is on the content library, which I'll be sharing with you in a bit, the links anyway. But this is a file that's available on their content library today. We call it Project Dryad. It's in alpha, but it's already fully functional. And I thought I'd dive in to the scatter mask because it already has, it's an interesting graph, and these examples are fully documented. And these tools are all built on the methods that I've been showing you up to this point, where it utilizes these basic tools. But what it does is the algorithms are all placed on the masks, and what mask generates what type of primitive to scatter those points into. So it takes away all of the R&D that you'd have to put into taking the tools that I showed you and building systems that do that minimize overlaps, builds it based on biomes, bond masks as well. So and it can work on either height fields or geometry style terrains as well. So pretty cool workflow, and it's built in a Houdini centric way in that all the nodes are all the inputs are inputted. They all have majority of them have help cards, and this is a really good example file that's generated by the labs team to show you how you can actually do all of your tools. And this is the main tool. It's Biome Plant Scatter, which is basically built on top of Scatter and Align. It's a digital asset, and it basically has pretty much the same inputs that you've seen before: scatter, multiply, density, multiply. It has a few additional parameters that are designed for working in a more scientific method, incomplete area coverage. So you can see which areas are not being covered the way that you thought, or invalid mesh path as well. So there's some debugging tools built into here. So really great set of, definitely take a look at this if you just want to get going right away. Just generate some biomes and get them into your engine and go. Or if you want to get them, I know that the labs team has been making sure that these work with Solaris. So the latest update now works much better with Solaris as well. So, and again, this is a great example file to have a look at, and it goes step by step over how to generate and use these biome tools inside of labs. Yeah. And so that's what I wanted to show. And one other thing to complete this is, so this is the website that you can take a look at for the biome demo. It's content library biome demo. Just go to the content library. It's right there. You can download the working files. You can watch the video that introduces this. And then there's also height field scatter. There's the help cards. They work quite well. And CG Ford has a really good scatter align SOP node bubble quick tip that was used for, and Rohan Dalvi, if you haven't discovered him yet, please take a look at what he's up to. He just released 1 month ago all the basics about copy to points and attributes, more in a general way. Not so much in a, are we building environments to do trains? But yes, definitely looks at copy to points, which invariably is all about scattering and using points and prims and attributes. And then Mardini, if you want to go to last year's, get some inspiration, we had a really cool Mardini present. We did a Mardini challenge. You can see all the various different ways in which you can use scatter and align SOP. And procedural desert. This is really, again, it's from our tutorial library called the Procedural Desert. And this is a couple years old now, from 2020. Coincides with scatter and align, by the way. And it's all about game engine scattering. And there's a really cool video in here called Scatter Model. So you construct your landscape first, then it shows you how to use scatter and align with masks to create complex scattering to avoid intersection using Quixel type prims. So that's a great video to go to next. And also covers some instances as well. And the next one is, yeah, this is just the Mardini. You can take a look at what some of the people did with scatter and align. Unfortunately, they didn't share files, but that would be cool if they did. And also finally the procedural desert, which I think I showed. Yeah, I showed you that already. So yeah, there's a few other videos out there in scatter and align, but very few cover the hierarchical workflows that I was showing you today by using tags and being able to use two or more of these scatter nodes to create these hierarchical systems. So there you go. That's pretty much what I wanted to cover today. Yeah, and let's get back to the questions and back to Houdini. Okay, so do these scatter tools work the same way in the Solaris instance? Or the answer is USD does its own way of doing scattering, where USD requires prototypes to be created and then it does the instancing. But if you're using the instancing setup tools, yes, it's the same. So I can quickly show that. Let's open up the other Houdini file. Yeah, like instancing inside of Solaris. Piece of cake. So let's go to Solaris. I'm going to my Solaris desktop now, so there's going to be a huge change in my desktop. Go. Oh, we're already here. So what I'm going to do is, as a matter of fact, we might as well use this because we have 3 SOP imports where we're building the meshes, and the third one has the prototypes. But we can do the same thing in here. So let's actually do something from scratch. So we have the instancer. Let's add a USD prim. Let's add a cube. And we can wire that into the instancer. Let's put that into the second input. And we can dive inside of here. And then we can put down a grid. And we can put down, let's just put down, just going to do really simple basics scattering. So let's put down a mountain. And let's deform it. And let's just do some scattering. Just put some basic points down. And let's put down like 30. And we go up. And then we get our scatter boxes. Now the instancer allows us to, let's put down a tube as well. Oh, it's called, they don't have a, let's put down a torus. And we can wire that in. So we got a cube and a torus. And then we can do the instancer. And it has the same settings that you have in the scatter align, in that you can actually, you can change how you distribute. Like you can put a random seed and you can change the different prims that you want to. So instance prototype primitives. So we can actually drag, this is sometimes a bit funky. I'm going to pin this, and then we can drag the cube, and then we can drag the torus. Do that. And now the instancer, if I unpin that, now the instancer will randomly put those on there, and then we can change the scale if we want to. But yeah, it has the same controls. If I go in here and we put down a P scale. Let's put down an attribute. Put down an attribute create. We're just going to put down a P scale. We can just scale it. So it's float, and we can put 0.01. And it'll actually pick that up too. And now they're too small. So I'm going to pin this double side in there, and I'm going to now start increasing this. And then you have the same, it's the exact same thing as I said before. All the instance setups inside of Houdini follow the identical rules. And we've built it up so that it all works. And as I said before, if we even put, let's put attribute adjust vector, and we can play with the normal, and we can actually play with that that direction. So we can change what is the look at direction if we wanted to. Remember I said normally that's the aim direction for the Z. We can now start playing with that. And direction and length. So we just want direction. So yeah, all the same attributes work the same way that they would in other systems. So yeah, you can change all of that. Yep. So there you go, instancing inside of, but here you can actually have all of your USD prims brought in, and then you can pass them through the instancer. And the next question. In the case of scattering points around existing object, is point replicate SOP the way to go, or is there a better way to do it? Oh, that's a good question. So let me go back to technical. And that's always that's a really common question you get a lot of the time. So if you have grid, scatter some points. Oh, I'm at stage. It should be an OBJ. Some geometry and put down a grid, scatter. And let's put a few points in there. Let's say like that. Let's copy some boxes. Copy the points, down a box. So we got the scatter points in there. Geometry we want to copy. And so now you have your prims on here. We have our grid. Let's merge them together. I think the easiest way is to use let's move our box up a bit. Well, we could so point replicate is great if you just want to put a cloud of points around a single point. But in this case, I would actually use as I said before, one of the basic nodes, which mask by feature. My brain just melted. Mask by feature. And mask by feature can actually work. And what's really cool about this, hit enter again, escape and enter. And now you can so you can actually do ambient occlusion. And it will calculate ambient occlusion around the boxes as well. So you could do it that way, and then you can scatter points around the areas where there are no boxes. So if you scatter on a line, and then you want to do by number of points, and then you can do by mask. So density attribute. Mask. It's doing it on the boxes as well, but yeah, I should have I should have put the shadow catchers down there for the boxes, but yeah, so. Yeah, but that would be one way to do it, is to use max by feature. I'm just sort of fumbling it around right now, but there is a way to sort of isolate the areas and get that to work. And that's to do. I'll remember that one. So just for myself, I'll just grab the text. Oh, I can't. Can I copy that? Control V. There we go. So the next question, what happened to the copy stamp node? I followed a ton of tutorials that use it, but newer versions of Houdini don't have it. Okay, so that was 18.5. So the copy stamp node, for those that don't know, you can actually still access it. And I'll show you how to do that. If you really, really want to use a current version of Houdini, and you really want to use an operator and it's been deprecated, I'll show you how to add an operator that's been deprecated. So if you really want to follow that tutorial, many times, if you're a clever Houdini person, but something tricky was being done and we deprecated the node, we can't remove an operator. We cannot delete an operator, because if we do that, then we invalidate previous scene files that relied on those nodes. So I'm going to put in here, I'm going to put opcf. And for those that know aliases, you can use CD, but I'm typing OPCF, and I'm going to say /obj/GO3, because I'm in GO3. That's what we're going to be working on right now. And I hit enter. And then I can put an op-add. An op-add will show me all the operators that are available. And one of them will be copy stamp. So why it got deprecated was because it's an old operator that didn't take advantage of compile. It couldn't be compile safed. And it was so old, we couldn't make it so it would work in a compile block if we had to. And it was just inefficient. So we replaced it with the copy to points with the workflow. And the copy to points now has that, as this single option right here, which is pack an instance, which deprecated the copy stamp operator. Because what that would do is it would stamp pack prims onto the points. But if you really want to do the copy stamp, I'm looking for it in here. So you can type in op-add. Yeah, I'm trying to find it in here. Yeah. So where's copy stamp? Oh, where is it? Copy with stamp. So that's an old one. Okay, so I bet you I know what I can do. So copy, if you want, you can actually turn on the display of all your assets. So if I go to the asset manager up in here, configuration, we can actually, we try and protect newer users or users that are artists and they just want to work with what we have. We actually have this thing called the asset definition toolbar. We can actually turn on show menu always. And then from there, we can choose previous versions of the asset. So in this case, it's not available to us. But yeah, you can op-add copy with stamp. So op-add copy. Yeah, but yeah, you could do that. I could figure, yeah, but you can op-add old operators and carry forward with your tutorials. Yeah. Too bad that's copy to points. I think that's it. So that's the old copy to points, which is copy stamp. I think that's I think that's it. Yeah. So again, you can turn on that option again in assets, asset manager, You can see all your operators, but you can go to configuration. It's more for power users or for Houdini users that are gone beyond beginner and they're starting to become intermediate users, and they want to see all the various different versions of assets that might be under some of these tools. As I said before, we can't duplicate, but copy to points is still there. Yeah, and we might op alias that to copy stamp. There you go. So asset definitions show always. There you go. Or show when needed if there are variations on an operator, it'll show. Okay, next question. What is the purpose of the second connectivity SOP? So let's go back up in oh yeah, in the Intagma setup. That's true. So what he has here is the first connectivity. I really don't know. So I'm trying to see here. Why would he have the second activity attribute class? Attribute class. I would say it would be redundant. You don't need that. That's the answer to that. I think that was just he might have I guess the artist might have put that in there thinking he could eat it later, but I don't think it has any use within this system. Next question, what uses are for this technique or controlled scatter used for VFX or any type of game movie? Everything is scattering. When you're building massive environments, like I showed you with the biome tools, you can use scattering for all kinds of things. As well, scattering sometimes makes for some great sources. One thing that Adam is going to be showing, the second version, is a pyro simulation. So we can actually take a grid. Like the scattering systems are useful for so many different things, from what we said from environment building, placing assets on props, and even our simulation tools will use seed points. And that was one of the things that Adam picked up on right away. Let's say we're going to do three. We are scattering 3 points on our ground. I'm going to hide other objects in here, so we just have 3 points in our scene. I can make them brighter there. And now we can put down a pyro. We can put down, let's say, a pyro. Any one of the, let's do pyro ground explosion. So this adds a script. And you'll notice that the first node here is explosion center. This is awesome, going full circle. I started off everything with an add SOP. The very beginning of this presentation where I was just showing how to, and here we have an add SOP adding a single point. But this is set up to, so basically what this means is I can push this aside. By the way, I can hit forward and you can get an explosion, by the way. I should do that just to show you where the explosion is. And there's my explosion. Okay, so there's my explosion. And you can see here that the add SOP is got some, it's basically adding the explosion. And then basically, I think you just point replicate the explosion centers. So we're basically animating the points here. And what we can do though, is we can scatter our own points. So this is what's generating the point cloud. If I display this and I press enter, you can see this is creating the points and it's also generating an attribute that basically it shows you how to do the points. So we can actually scatter our own points now and generate our own explosion centers. And let's make our grid a bit bigger. So yeah, all of our tools are based on scattering. So you can even scatter initial locations for explosions. And all of our tools are set up to do the same thing. Now let's bypass the point replicate. Now if I press forward, I'm going to have those, if I move my display flag to the bottom, and then I press forward, it should pick up those and you can see now I've got the 3 explosion points. Now there's some timing controls that are set up inside the workflow, but yeah, you can use scatter points to determine all your various different explosions and time them how they go based on the points you scatter. So yeah, scattering is everywhere. We use it as you now, hopefully now as you're starting to use Houdini, our developers are very clever and they say, well, I'm anticipating that a power user is going to be scattering points into this because they probably want to place them procedurally. So by just stopping, taking a breath, put down any one of your tools and interrogate the inputs. And if it looks like it just takes a few points, it's fair game. And by the fact that we put an ad stop in their screams, replace this with your own point cloud. So there you go. The next question, is there a way to scatter based on slope rules, like setting the min and max slope and also do a ramp for users? So that comes down to measuring as well. So I think I did that, but let's do it again. I think I already did that in height field scatter when I answered the one question over here, or where I compared the two versions. No. Yeah, let's do this from scratch. And let's put down a grid. So, and mountain, you can use the measure saw to interrogate your mountain field. So let's actually add more divisions. Again, you can add so there's my mountain. Let's add a little bit more amplitude to that. And then you can use a measure. And some of the things you can measure is height. So you can measure the area, you can measure the curvature. Let's actually add a lot more. Let's add 200. Add more prims to this, we can actually get some more. Oh, I want to do it on the points. And we have a gradient here. And whenever you have a gradient with curvature, you can then remap that attribute to whatever it is that you want. And I think we actually have there is another tool that does exactly what you want. I just don't know the name of it offhand, but there is a particular node that allows you to interrogate the tool. Could be under labs, building, terrain. But again, this is where height fields come in. Height fields have a lot of these built-in tools for you already. Whereas with the measure sop, I then have to do a fit range. Attribute adjust float. And it's measuring.
Hey, Jeff.
Yeah.
Bailey,
Oh, but anyway, I can work on that later. Yeah, we're
I
running
was
out of
just gonna
time.
say Bailey Hogan side effects is Bailey Hogan, the famous Bailey, said height field mask by feature is what I'd do to get slope.
Yes, that's what I want. Yes, I'm sorry. I knew there was a node. I'm sorry about that. Thank you, Bailey.
Thanks, Bailey.
I did plug the biome tools, which are like freaking amazing because they do everything for you. But yeah, there you go. That's what it is. So that's height by feature. So escape enter. And sometimes when you can't see the attribute, yeah, so there you can actually do mask by slope, mask by height, and a mask by curvature. But let's actually just do maps by slope, and you can adjust the range you want there. And there. Yeah, I'm wondering where's the visualizer for that? Yeah. There usually is a visualizer for this, but yeah. And then you can scatter based on that. So that's generating curvature attributes. So you can actually scatter on curvature if you wanted to. Or scatter. Yeah, we can just do scatter by density. Scatter. Actually, no, I have to do scatter. Align.
Maybe it needs to be converted to height field to see the mask visual.
Oh, I could do that. Yeah. Scatter align. So by density attribute curvature. let's do a lot more. Let's do by number, and let's add a ton of points. So there we go. And then I can just do ask my, and you can adjust the range that you want to scatter to that.
Dane recommended that you could also use a visualize node.
Yep. Oh, I know what I could do. I'm just stupid. You can actually do it right from here. So any one of these attributes, you can visualize them just by turning the display on. I'm a moron. Yep. So you can just pop up the info and you can actually visualize any attribute you want right from there. So you can see.
Pretty sure no one was saying Jeff is such a moron.
No,
Okay, next
I am. I
question.
say that to myself. Okay, so there you go. So mask by feature. So the next one, how can elements be correctly scattered on complex? Okay, complex surfaces such as a diamond-shaped roof. For more intricate forms, is there a universal way to accurately generate normals? So the answer is for complex surfaces, it's all resolution. So if I was to, let's say if you had a tiled roof and you wanted to add some, some moss, maybe, or just some moss on the shade line between the two tiles to create some really cool weathering effect or something like that. Yeah, you could certainly, yeah, there are approaches to do that. Not everything up by default, but you could probably do different types of masks to control where it is. But there is, first of all, the universal way to generate normals. So let's just put down template head. Well, the universal way to generate normals is with the normal SOP. So maybe that's where the question goes. So we can turn on my normals in the viewport here. And you can visualize them there directly. And so there are different ways to generate the normal by face area, vertex, angle. But you can also use attribute adjust, vector. And that gives you an awful lot more control as to how to generate the normals. So N. And yeah, but attribute just normal generates them based on the normals. And then you can actually pass that into the attribute just vector. And you can now modify, you can add, subtract, multiply. So you can add, for instance, some different ways of working. You can add a little bit of noise to that. And you can display your normals. Not add, but let's multiply. What? Direction only. Just do the direction only. Oh, size. Yeah, I wonder why that's not working. But yeah, but there are ways to, as I said before, the normal SOP generates the normals. I'd have to actually take a look at like an actual case to see how to approach it. The next question, how can elements be correctly scattered on okay. I would love to have an example of that to see how we could work on that. So the next question is, how compatible are those biomes with Unreal PCG? So I do believe the biome tools themselves generate, they generate their own data. They work. I think Bailey does cover that in the videos as to how to export these into Unreal. And there are ways of integrating our setups with PCG. But I can't answer the question as to whether or not our biome tools are set up to be modified by PCG inside of Unreal.
Yeah, I asked her in the group chat, and she
Follow the tutorial. There you go. That's what I thought. Yeah.
Thanks,
So there
Billy.
you go. Because I know the two together, I just couldn't definitively say if we did. I do remember watching a video on that.
Cool.
So
We've
another
got
question, a lot
one
of
minute left,
environment.
Jeff.
Yeah,
One
a lot
minute
of
left.
environment artists are using speed tree models with opacity maps for leaves. We variable useful. There's a Houdini node to convert these maps to geo without having to rebuild the asset too much. Absolutely. I think that would be a really good tip. I'm just going to capture these tips in there. Just capture the tips in the notes because we're running out of time. So a lot of environment art. Okay, so and the other two are done?
Well, we'll just get this last one.
Okay. So a lot of environments, so that's the speed tree ones. Um, if there was a Houdini node to convert these maps to GIR without having to rebuild the asset too much. I think one of the answers to that is baking. I know the labs baker is really useful for taking a lot of these models with opacity and baking it to geometry and texture maps. But we can you're absolutely right. There could be a labs tool if there's not one already that can take let's say a leaf that has an opacity map with it and then does that. But we do have this is one way to finish off. We do have a trace solve, and a lot of people don't know that. And we do ship with a leaf texture map. So let me go to let's go back up, and I do think we have a leaf texture map. So this is cheap and cheerful, and it even generates UVs. There we go, maple leaf. I could even use the alpha if we wanted to. And so you can quickly take any geometry and you can then use the trace sop to convert that into geometry. You can add UVs. And the trace sop, where's the add UVs? Cop. I think it automatically adds UVs. Yeah, but somewhere it adds UVs as well. Where are the UVs? I know it does have UVs in here. Add point texture. Oh, this node is so old. This node goes all the way to prisms. And of course it says add point texture and doesn't say add UVs. Oh my good Lord. But anyway, that's a great way to end it. But anyway, so yeah, you can trace it and then you can create your geometry. And you can even use a labs quick shade. Labs quick shade. Oh, UV quick shade. And then you can put your leaf texture map on that.
Chris Chapman says the trace sop reminds him of the old OG cookie sop.
And there you go. So if I had to process a ton of geometry, I'd actually put this inside of a 4H block, obviously. But this is a great thing for labs to do. I mean, one of the things that labs set on early to do was to simplify a lot of the workflows inside of Houdini. And so we were able to generate a lot of tools that took a lot of these esoteric workflows inside of Houdini and built them into these one-offs. So that'd be really cool if we could just have like a leaf process or take any geometry with opacity on a card and then generate the geometry and spit out the texture map. There you go. Hopefully that was one way to do what the op asked to do, what Will wanted to do.
Awesome.
Yeah.
Thanks, Jeff.
Okay. Thank you, everybody.
Always a pleasure. Thank you, everybody, for
Yeah,
showing
we're gonna
up,
do more of these.
participating so much. Great questions along the way. We're going to publish this in the next day or two, and we're going to do a whole round of Illums this year, right, Jeff?
Oh yeah, I could do these anytime. It's like for me, it's like breathing air, right? Stretch me out. Yeah, I'd
Drinking
get me
maple
into
syrup.
areas I'm not comfortable with as well. Okay.
And I
Goodbye,
mentioned
everybody.
in the group chat, but I'd love to see all of you at Houdini Hive Equinox in September. It's going to be
I'll be there.
in Toronto, September 22nd to 25th. Well, it'll be like a hive like we normally do anywhere else, except that it's going to be in Toronto. So you'll be able to hang out with our staff and the presenters will all be here and we'll be hanging out and having a beer and it's going to be awesome. So love to see you there.
Absolutely.
See everybody soon.
Okay, bye, everybody.